In the previous video, we set up our provider. So now let's jump right into setting up our first resource. So in order to do that, we have to go to registry.terraform.io to find the resource that we want to use. Franx Fiberworx. That is not the resource that we're trying to use. My brother and I created a company to manufacture fiber parts for cars, boats, airplanes, or spaceship parts, or even drone parts. Whatever you need carbon fiber, we'll see if we can make that for you. Anyways, let's get back to the video. In this resource, we're going to be using the AWS _VPC resource. I'll put the link to this in the description below. We're going to be using the example usage. So here we can see a basic usage to plug in this resource. We can add in the resource name, and then the main is just the name that we're going to name that resource usage in our instance. And then we get a little block here where we can specify the CIDR block or the subnet that we're going to be using this resource in. So this is a virtual private cloud, and this is a subnet range that we're going to be using for that virtual private cloud environment. We can also put in some tag options, like we can tag it with the name. We could put in some other stuff. Let's go ahead and use the one with tags. The one with tags and the one without tags is going to function exactly the same. The only difference is that tags just kind of gives you additional information, but it doesn't make it function any different. So let's go ahead and hit copy. Our resource is AWS VPC. For main, we can just rename this to Hungarian VPC. Then we have a CIDR block. This is our subnet mask /16. And you know what? Let me try a /24, because /16, we don't need that many hosts. We only need like 254, not even that. For instance tenancy, we can leave this as default and get into that in a different time. The main part here is tags. We can do name equals main. We can rename this to Hungarian VPC, and we can even give it another tag like environment equals dev for development. And now, in order for this CIDR block subnet to work correctly, we need to create a separate resource that will be the AWS subnet resource. To do this properly, we first have to spell resource right, source. And then here we can do Hungarian subnet. You know, it's not a German one, it's a Hungarian one. Okay, so then we put in VPC ID. And where am I getting this from? Well, if we were to go over here and type in, I think it's subnet. Yeah, so here it asks for the VPC ID. And here it's showing that the VPC ID example is AWS VPC main ID. So we can go ahead and copy this over, paste it in here. But this is not going to work in our environment because our VPC isn't called main, and this is referencing main. So we can just delete this and go Hungarian, you autofill it, ID. So this is going to be the ID of our virtual private cloud here. And even though this is not created yet, this resource is just going to refer over to this block. Now, if you already had a VPC created, when you do this, then you just put in the VPC ID. So then you just delete this and then put in whatever ID is already created in your AWS environment. And here we can also specify the CIDR block as well. So what this CIDR block is essentially we're taking this one and subnetting away from it. So right now in our entire VPC, in our entire environment right now, we have a /24 CIDR, which gives us 254 hosts on the same network. But when we create this subnet, we're essentially creating our own little sub network, our lesser network inside of the main network. It's kind of like a VLAN if you're doing Cisco stuff, like you have a big CIDR and you do some VLSM to subnet the different IPs, split them up, and then you have different VLANs with different network IDs. So this is kind of like that. So we can go something like out of that 10.000/24, we can do a /28. So for /28 we got 16 IPs available, but one is the network ID and one is the broadcast ID. So actually we only have 14 available hosts, so we can set up 14 systems inside of the subnet, which is good enough for this lab. And then we can also set up where the availability zone is for this subnet. So we can do, and where did I get the A from? Well, this region up here might have multiple instances of the same region, so the A at the end is specifying that that's the first instance of this region. So now that we've got our base template written down and set up, I'm going to go ahead and save this. Then I'm going to go over to my AWS Management Console or the portal, and we'll go to IAM to manage our users. And after the last video, I went ahead and I actually disabled this. So I'm going to go ahead and go into this user and we'll go to, I think it was Access Advisor, maybe a security credential. There it is. So I'm going to reactivate it for this video because you guys have my key for this. So remember, because that I showed you guys the key to my account, whenever I'm filming and whenever this account is active, right now at this exact moment, you could be hacking into my AWS account and doing malicious activities. And I'm totally risking it for the biscuit because I'm going to deactivate this as soon as I'm done the video. So anyways, now that that's reactivated, now I can go ahead and use this admin account to push out my change. And we'll be implementing these resources with a command called Terraform Apply. So in order to use Terraform Apply, we got to go over to our PowerShell module, and I'm going to go over to, I was in the projects, nope, projects, there you go. So here's my Terraform file, and then I go into the Terraform, and from here I do type in Terraform Apply. So after we type in the command, we get this big input. Terraform is kind of walking you through everything that it's going to do. So Terraform will perform the following actions, and it's going to do this in this order. So it's going to create an ARN, assign IPv6 address on creation, and ARN is, I think, if I'm not mistaken, that's where it's getting the IPv6 address from, because that's like the internet resource place that owns all the IP addresses. It says false, so it's not going to go there and give us an IP address, or not an IPv6 one anyways. It's just going to give us the CIDR private IP subnet block that we gave it. So this is the CIDR block we're using, and it's not going to create DNS. It's not going to put in the DNS records, the ID and the association ID. It just kind of goes through all this stuff step by step. Then next it's going to create that virtual private cloud. So we get this CIDR block, we go through here, and this one does enable DNS support by default, looks like, and then the instance tenancy, which is default as we wanted it to be, and then we get the environment. This is the tags that we put in, and then here we got a couple options. We can press 2 to add, or we can press 0 to change, or 0 to destroy. And Terraform will perform the actions described above. Only yes will be accepted to approve. Okay, so I was wrong. You don't press 2 to add. So in our plan, Terraform plans to add 2 things. It plans to change 0 things, and it plans to destroy 0 things. If we accept, then we will press yes. So we type in yes, press it, and we create this, complete it in 2 seconds, then we create the next one, complete in 0 seconds, apply complete. That looks good. So one last point before we move on, I'd like to point out these green little plus signs. Those plus signs mean that these are adds. If there were little red minus signs, then that was destroy. So with that being said, let's go over to our AWS Management Console, and we can go to VPC, click on that, and we go to VPCs. And as we can see, we've got 2 virtual private clouds. The first one is Hungarian VPC. Then we got this other one. What is this? So now I never set up this VPC. I only set up this one. So let's take this VPC ID and check it out. Let's go to Subnets and stick that VPC in there. I think this might just be a default VPC that comes with AWS. But anyways, the point is that here we have a Hungarian VPC. Here we can see the CIDR block that we put in is /24. And if we go to Subnets, we can see that here we've got that /28 that we set up. And if we expand this VPC, we can see that that's a Hungarian VPC, the one that we created, and it's got available 11 IP addresses. I thought it was be 14, but I guess AWS VPCs might have a couple other devices virtually that is connected to, which would bring us down to 11. That would mean it's connected to 3 other devices. Those could be monitoring endpoints. Maybe the ARN has an endpoint. If we go to route table, let's see what it's got. I'm definitely more familiar with Azure than I am with AWS, but we got our subnet and we got our VPC. One other thing to check out is the tags, and I can see we got environment and name. So now, what if we wanted to create another sub? Well, we can maybe copy paste this here and type in Hungarian subnet and then do like a .16 here. But this wouldn't work because this is the name of our VPC within this infrastructure as code, but that's for the setup part. So this is no longer really going to work the way that it worked before, because this one is relying on the creation of this VPC. But since this VPC is already created, this might not be the best way of putting in the VPC ID, because the VPC ID is actually different now. Now if we go into our VPC in the portal.amazon.com, or sorry, aws.amazon.com, not Azure, if you take and you copy this VPC ID, you could stick this into here and edit it like that. But what if you had like thousands of resources and maybe you don't even have access to this AWS Amazon console? Maybe you have thousands of VPCs in here, you don't want to navigate through everything. Maybe you don't want to go to this web at all because you don't want to navigate through the user interface. Maybe you just want to do everything from Visual Studio Code. You don't want to go to AWS. You can do that with an option called data. And data is like a query tool that refers to anything in Terraform's state. And Terraform state, as we talked about in previous videos, is everything that Terraform knows about in our infrastructure environment. So data, we're basically looking for things in that state file. So, because that state file knows everything that's in AWS. So why do we need to go through AWS to do something or define something when Terraform already knows about it? So we're going to use data. We'll do AWS VPC to specify the resource that we're looking for something for. Then we're going to type in existing VPC, which could just be like a name for it. Then we're gonna put in these curly brackets or braces, they're actually called braces. And in order to find what we're gonna put into this data function, we can go back over to Terraform. I'm gonna delete subnet here and type in VPC again. If we scroll down, then we got all these argument references. So these are the references that we're gonna look for. And I'm looking for, so basically what these are is, you can use the CIDR block to be like, give me the VPC that has this specific CIDR block, and you can like specify it. Or you can do, there's a default option, maybe it's somewhere else, but I'm just gonna type in default. We'll see if this works or not. And my default value is just gonna be true. So then from here, we're gonna do resource, or you know what, instead of true, let's go ahead and specify the CIDR block 0/24, and then our resource is going to be AWS VPC, and this one's going to be Hungarian Subnet 2. I'll put in some braces here, and the VPC ID. Now up here in this resource block, we had AWS VPC Hungarian nerd VPC ID, but this one we can do data dot, see this one, we're referencing this variable. See, I'm highlighting this, and this also gets highlighted because it's like these two words are the same now. They're going to be referencing the same thing. So now we type in AWS VPC dot existing VPC dot ID. So now what this does is it's going to take whatever this found, because this is kind of like our data variable for this. It's going to take this and find the existing VPC based on the CIDR block that we gave it. And the VPC that this finds is going to be outputted, and we're going to grab that output with the data dot and stick it in here. And then we're going to do CIDR block 10.0.0.16/28. And this is just VLSM stuff. If you don't know how to subnet, then maybe we can make another video of that. Maybe I could put a link in the description below where you can learn how to do that. But essentially, this is the next network ID if we're doing /28 subnets. Next, we'll go to the next line. We'll stick in the availability zone. And this one will be US East 1A, just like the other one. So now that we've got this resource block with the coming from our data block, we can go back into Terraform here and try to do another Terraform apply. Let's see if it works. Terraform apply, and there's no changes. So there is no changes because we didn't save this. So we got to save this first. Control S for save, and now let's rerun this apply. Okay, it looks like I messed up here. So let me look over this. We could just try something different. So we can go with that original plan to do default. If it's default, then we do true, or true like this. So what this is doing is taking the default VPC. So that was the VPC that we saw back here that was already created with this IP address. So this is natively here in AWS when you set up your account. We can just grab that CIDR. We could put that CIDR IP here, and we could just subnet this to create the next IP block as so. And if we hold down Control, press S to press save, then we can try this again. Alright, so let's check out this VPC ID and put it into the subnets. If we see here, I guess we already have the subnet that I tried to spin up, and that's maybe why it didn't work. If I go over here, the availability zone, we got one for A, B, C, D, E, F. Maybe if I try G, let's try G, and then let's sort these CIDR addresses so it goes up to 80. So the next one's going to be 96. So let's try that out. Hit save, then let's try this Terraform Apply one more time. And there you go. So now it's working. So I think the issue that we were doing is we didn't have the right availability zone and we didn't have the right CIDR block. So when we hit yes, this is going to work. Or it doesn't work. It doesn't like 1G. So maybe we do need 1A. Terraform Apply. We hit yes. Now is it going to work? No, it doesn't like 1A. Subnets can currently only be created in the following availability zones. US East A1. Didn't we use 1A? Oh, it's showing US East. And I'm using US West. Right, because... See, I got a typo. Save that. Let's run Terraform Apply. Round 3. Type in yes, and it's complete. So this creates that subnet. But what if we want to make this one? Let's try that out. Let's do CIDR block equals 10.0. We're gonna do 16/28, and then for here we're gonna do, that's fine. It's gonna be Hungarian subnet 3, and then this CIDR is gonna be 10.0.0.16.28. No, this is the 16.28, and this one is going to be referencing the one that already exists that we're trying to VLSM. And then here, we have the East 1A. Let's see if this works. And it's showing that subnet 2 will be destroyed and this one will be created. And it's showing that, and yeah, here you can see where we get the little red minus signs now, but I'm going to hit no for this one. So anyways, we can go back to the subnets, to the VPCs, and we can verify that we did create this new subnet up here, the .96, and here's the availability zone. We put it in 1A. So now that we know all this works, that will be the end of this video. Thanks for watching, and I'll see you in the next lesson. I know we had a couple bumps in the road, but we got through it.